Hey everyone, welcome back. So today we're going to be solving another question, diameter of a binary tree. This is an easy question and I'll be coding it in Java, but the solution, the logic to it, the intuition, it's going to remain same across all the languages. So yeah, let's start. Basically the question is asking us, given a binary tree, you need to return the diameter of a binary tree, right? It's very simple. What's a diameter? Diameter is nothing but is the length of the longest path between any two nodes in a tree. Okay, it can be any nodes. It can be this node, or this node, this node, or this node, this node, or even this node and this node. It can be any node, right? So basically, we need to return the longest path between any two nodes in a tree. Okay, this part may or may not pass through root, but that what they mean is your tree height, your tree's diameter can also be this, right? If you see over here, this particular path that we are having is not passing through the root, right? So my diameter can also be this, right? It can be 2. This is 1, this is 1, right? But is this the longest diameter? No, there exists a better one, which is nothing but this one, right? Because this is from this side, you're having a diameter of, not a diameter, length of 2. And then from this side you're having length of 1, so your max would be nothing but 3, right? This is what we need to return. Before we solve this problem, there's a prerequisite, and that problem is nothing but it's nothing but maximum depth of a binary tree. Please watch that video of mine. I have completely explained on how to calculate the height of the tree for a given node or for a given edge. Okay, please watch that video before you come to this. It's called as maximum depth of a binary tree. Okay, please watch this video before you come to this, so that you have a complete understanding of how to calculate the height of a tree in terms of node or in terms of the edges. Okay, now let's get started. Okay, now very simple. Okay, can I say that my maximum diameter, okay, for any binary tree would always be my length, that is the number of edges on the left node plus number of edges on the left node plus the number of edges on the right node. Can I say that? If you take any tree, a tree can be like this, okay, and then you can have another tree 3, 6. Can I say that my maximum length would be maximum diameter would be 1, 2, 3 from this side, that is the left side, plus 1 from here, this side. So my maximum diameter would be 4. I can say that. So I need to know, okay, so now I have an idea. Okay, the depth would be nothing but the length on the left side and the length on the right side. Perfect. Now, so how can I use this to build my logic? Okay, so it's very simple. Okay, let's think about it. For a given node, let's take any node. For now, let's consider this parent node. Okay, for this node, what do I have to know? I have to know my left height and then the right height. In terms of what? Not in terms of number of nodes, but in terms of the edges. By that, what I mean is the height of the tree in terms of edges is 2, but the height of the tree in terms of, for this entire subtree, the height of the tree in terms of the number of nodes is nothing but 3. But what do I want? I want the height of the tree in terms of the edges, right? So for a given node, I need to know, okay, I need to know the left height and the right height. If you know the left height and the right height, I can say that, hey, I can add the left height and right height and see if that is my maximum value. If it is my maximum value, I'll update it, or else I won't update it. Okay, we can probably have something like a global variable where we can have the max value, okay, initially set to a min value, and then if my left height and the right height is left height plus the right height is greater than my max value, in that case I'll just update it. Okay, because for because for every node there can be a max height, right? So what I'm trying to say is, you can ask me a question, hey Siddharth, can you not just calculate my left height from the root node and the right height from the root node? No, the question is clearly saying that the longest diameter may not pass through the root. So by that what I mean is, what if my node is like this? What will be my height this time? Wouldn't my height follow this path? This would be my height, right? This is my maximum height. But is this height passing through the root? No, it's not. It's passing through 2, right? Which is nothing but this particular subtree, right? So you cannot say that just calculate the left height of the root, right height of the root, and then add it up. You cannot say that, right? So you need to know. So for any node, right, we'll calculate the left height and calculate the right height, and all we'll have to do is add it up and check if it's greater than our max value. If it is, we're gonna add it up. I mean, we're gonna update it. Else, if we're not gonna update it, we're gonna move on to the next one. Perfect. Okay, that's exactly what we'll be doing. And the recursion that we're gonna be following, I mean, the approach that we're gonna be following is a recursive approach. It is a DFS approach, and it is specifically post-order traversal. Right? What is post-order traversal? It's nothing but left, right, and then the node, right? Right? So what are we doing? We're calculating the left height, we're calculating the right height, then we're performing the calculation. Okay, so we're going to be using post-order traversal. Okay, perfect. Let's code it up. Okay, so let's have a global variable which will have something called as the int max diameter is equal to integer dot min value. Perfect. Now what I'm going to do is I'm going to have a recursive call. This is going to have a return type of int. Okay. If you're not understanding or having a confusion on why we're using it, please watch my video on maximum depth of a binary. Okay. Recursion of I'm going to have tree node as root, and then I'm gonna check if my root equals to null. What I'm gonna do is I'm gonna be returning 0, okay, because diameter would be 0, and then what I'm gonna be doing is int left equals to, I'm gonna be calling recursion of root dot left, okay, and int right would be equal to recursion of root dot right. Okay, then what I'm going to be doing is once I've gotten the left, okay, let me name it better, left height and then the right height. Okay, once I've gotten both, what I'll be doing is I'll be checking if it's my max value. Max diameter will be math dot max of left height comma right height, sorry max diameter comma left height plus right height. Okay, else what I'm going to be doing, returning math dot max of left height math dot max of left height comma right height plus 1. Why we having plus 1? It is nothing but the, like, we need to consider the node as well, right? For a node, we're going towards the left, we're going towards the right, then we're coming to the node. We need to consider the node as well. Okay, so that's why I'm having plus 1. So yes, our recursive call is done. So what we're going to be doing is we're going to be calling a recursion of root. Okay, once you've done that, then what we'll do is we'll just return max diameter. Perfect. Let's see how this runs. Okay, I got a compilation. Oh, sorry. Switch. Oh, you know what? Let me call this as left height itself. Perfect. Let's submit it. Perfect. Okay. And what would be a complexity? You're traversing through ideally every node will be O of n, and your memory will also be O of n. Right? Yeah. I hope you understood the solution. Thank you so much for watching, and please do subscribe.